In this question, we're going to graph the curve y equals 4 cos of 2x minus pi minus 4. Ultimately, the curve looks like this, and we're going to take a look at how we got there. The first thing we have to do is ask ourselves what the parent function is. Since the leading coefficient of 4 is positive, and since it's a cosine curve, our parent function will be y equals positive cos x. And y equals positive cos x looks like this. It starts on the maximum point, goes down to the axis of symmetry, down to the minimum point, up to the axis of symmetry, and back up to the maximum point. Alright, well, how did we figure out how to graph that curve? We followed a series of steps. The first thing we did after determining the parent function was to determine the equation of the axis. We then determined the amplitude, the phase shift, the period, the coordinates of 5 points, and we graphed it. And in this case, we're answering question B. Okay, well, first thing we had to do was to factor the 2 out of the argument, giving us an argument of 2 bracket x minus pi over 2. We then realized that our parent function was y equals cos x, as already indicated, and our axis was at y equals negative 4. The y value of our axis is always going to be equal to the c value in the given function. And our amplitude was positive 4. The way that we got that was by taking the absolute value of the leading coefficient. In this case, it was a positive 4, so that was our amplitude. And by making those decisions, we're able to then say our axis of symmetry is negative 4. We begin at the maximum, which is one amplitude above negative 4, and then we go down to the axis of symmetry, down to the minimum, back up to the axis of symmetry, and back up to the maximum value. We have our y coordinates, and now we take a look at our x coordinates. Our phase shift is pi over 2 to the right. We got that after factoring the 2 out of the argument. We got that by looking at having x minus pi over 2. So in other words, we had a d value of pi over 2. That's our phase shift, and that's going to be our initial x value. Our period in this case is 2 pi over 2. Well, if you're wondering how we got that, it's because the period is always 2 pi divided by the absolute value of k. In this case, k is equal to 2. So 2 pi over 2 is equal to pi. Since we have 5 key points we're looking at, we can divide our period into 4 equal intervals. And here's what we mean. Ultimately, we have 5 key points given by these black dots. And if you look, that means that we actually have 4 equally lengthed intervals horizontally. Okay? So how are we going to decide how big each of those intervals is? Well, we're going to take our period and divide it by 4. Pi divided by 4 ultimately equals pi over 4. So we can, what that means then is that our initial x value is pi over 2, and from there we can add pi over 4 to each x value to get the next x value, and we can plug them in next to their corresponding y values. Doing that leads to these calculations. The first x value is pi over 2, and then it's 3 pi over 4, and then it's pi after adding another pi over 4. Then after adding another pi over 4, we get a fourth x value of 5 pi over 4, and finally an x value of 3 pi over 2, leading to these 5 points. From there, we have to decide how to scale our x-axis and our y-axis. Well, our y-coordinates are all fairly simple integers, so we're going to scale, and they're all of a appropriately small size, so we're going to be able to scale our y-axis by 1. But our x-axis is a little bit more complicated, perhaps. We see that we have a lowest common denominator of 4, so we're going to scale our x-axis to be pi over 4 units long. Every square to represent pi over 4 radians. And so therefore, we can plot our 5 points. Our first point is pi over 2, 0. So we have to come 2 squares over from the y-axis. We can plot the remaining points and draw an appropriate looking cosine curve.